In this video, we're going to walk through how to correctly size the electrical conductors for an air conditioner. This applies whether you're replacing an existing unit and want to confirm that the existing wiring is adequate, or you're installing a new air conditioner from scratch. Everything we cover here follows the National Electrical Code, specifically the rules that apply to air conditioning and refrigeration equipment. Why air conditioners follow different NEC rules. Air conditioners are not wired the same way as general lighting or receptacle circuits under the NEC. The compressor inside an air conditioner uses a hermetic motor, meaning the motor is sealed inside the compressor and cooled by refrigerant rather than open air. Because of this, air conditioning equipment follows NEC Article 440, which includes special rules for conductor sizing and overcurrent protection. This is why air conditioning circuits often look different from standard branch circuits, and why it's important to follow the correct article. Before we begin, this content is for educational purposes only. Electrical work can be hazardous and should be performed by qualified or licensed professionals in accordance with applicable codes and regulations. Always start with the nameplate. The most important rule in sizing conductors for an air conditioner is this. You always start with the equipment nameplate. Every listed air conditioning unit is required to have a visible nameplate that provides the electrical information you need. The two key values on the nameplate are minimum circuit ampacity, commonly labeled MCA, maximum circuit breaker or fuse size, sometimes labeled MOCP. These values are provided by the manufacturer and already account for motor characteristics, starting current, and internal loads. If the nameplate gives you these values, your job is not to recalculate them. Your job is to verify and apply them correctly. Understanding the 125% rule. The NEC requires that branch circuit conductors for air conditioning equipment be sized at 125% of the rated load. However, in most modern air conditioning equipment, this calculation has already been performed by the manufacturer. The result of that calculation is shown directly on the nameplate as the minimum circuit ampacity, or MCA. So when you see an MCA value, the 125% factor has already been applied. Why we use the 60 degrees Celsius column. Even though many conductors have insulation rated for higher temperatures, conductor ampacity is limited by the lowest temperature rating of the terminations in the circuit. For small HVAC branch circuits, terminations are often limited to 60 degrees Celsius due to disconnect lugs, equipment terminals, cable type limitations such as NM cable. Because of this, the safest and most commonly applicable approach is to size conductors using the 60 degrees Celsius ampacity values from the NEC Table. This avoids assumptions and aligns with real-world inspection and installation practices. Worked example using the 60-degree column. Let's walk through a real-world example using an actual air conditioner nameplate. The nameplate shows minimum circuit ampacity, 17.8 amps. Maximum circuit breaker, 30 amps. Step 1. Select the conductor. We now go to the NEC Ampacity Table 310.16 and use the 60 degrees Celsius copper column. At 60 degrees Celsius, copper conductors are rated as follows. Number 14 copper, 15 amps. Number 12 copper, 20 amps. Because the required minimum circuit ampacity is 17.8 amps, a number 14 copper conductor is not sufficient. The next standard conductor size is number 12 copper, rated at 20 amps, which exceeds the 17.8 amp MCA. Number 12 copper is the correct conductor size for this circuit. Step 2. Verify the circuit breaker. Next, we verify the overcurrent protection. The nameplate allows a maximum circuit breaker of 30 amps. Under the special rules of NEC Article 440, this breaker size is permitted, even though number 12 conductors are typically associated with smaller breakers in general-purpose circuits. If the conductor meets or exceeds the minimum circuit ampacity and the breaker does not exceed the nameplate maximum, the installation is code compliant. Final compliance summary. Let's summarize the installation. Required ampacity, 17.8 amps. MCA. Selected conductor, number 12 copper, rated 20 amps at 60 degrees Celsius. Circuit breaker, 30 amps per the equipment nameplate. This installation meets the NEC requirements for air conditioning equipment. Always verify installations against the current edition of the NEC and local requirements. At this point, it's important to clarify something that often causes confusion. In a typical residential outdoor installation, we are using THHN or THWN2 copper conductors, which are rated for 90 degrees Celsius insulation. You may notice that THHN and THWN conductors are not listed under the 60-degree column heading in the NEC table. That does not mean they can't be sized using 60-degree ampacity values. The NEC requires us to size conductors based on the lowest temperature rating of the terminations in the circuit, such as breaker terminals, disconnect lugs, or equipment terminals. Even though the conductor insulation is rated for higher temperatures, we intentionally limit the allowable ampacity to the 60-degree column when terminations are rated 60 degrees. This is normal, expected, and fully code compliant. It's also why you'll frequently see 90-degree rated conductors sized using 60-degree ampacity values in real-world installations. Key takeaway. This example highlights why air conditioning circuits must be evaluated using Article 440, not general wiring assumptions. You cannot simply look for the smallest wire that clears the load on paper. You must consider termination temperature ratings, wiring methods, and the manufacturer's nameplate instructions. When in doubt, using the 60-degree Celsius column provides the most conservative and defensible result. Sizing wire for an air conditioner isn't about memorizing formulas. It's about knowing where to look, understanding which NEC rules apply, and following the equipment nameplate. If you apply this process consistently, you'll be able to size air conditioning conductors correctly and with confidence. If you found this video helpful, be sure to check out our HVAC and plumbing estimating spreadsheets to streamline your construction bidding process. Check out our HVAC, electrical, and plumbing construction forms to help you run your business, and explore our online courses for in-depth training.